Hello everyone. In this video, we'll be seeing about the engineering materials. So in the previous videos, we saw about the few classifications. Still more few classifications are discussed in this video. So now let's get into the topic. So here we are going to start with the ceramics. Ceramics are a solid compound that may consist of metallic or non-metallic element. The primary classifications of the ceramic includes glasses, cements, clay products, refractories and the abrasives. Ceramics generally have an excellent corrosion and wear resistance, high melting temperature, high stiffness and low electrical and thermal conductivity. Ceramics are also very brittle materials. If you are summarizing their properties, we can say that ceramics have high melting point, great hardness and strength, considerable durability, low electrical and thermal conductivity, and a chemical inertness. So next one is about the glasses. Glasses are common materials and are seen in applications including window, lenses, containers. Glasses are amorphous, whereas other ceramics are mainly crystalline. Primary advantages of glasses include transparency and ease fabrication. The base element of most glasses is silica, and other components can be added to modify its properties. Common process used to form glass include heating until melting, then pouring into mold to cast it into useful shapes, heating until soft, then rolling, heating until soft, then blowing into desired shapes. An optical fiber is a flexible transparent fiber made by drawing glass, silica or a plastic to a diameter slightly thicker than that of a human hair. Optical fibers are used most often as a means to transmit light between two ends of a fiber and to find wide range of fiber optic communications where they permit transmission over longer distances and a higher bandwidth than electrical cables. A cermet is a composite material composed of ceramic and metal materials. A cermet is ideally designed to have the optimal properties of both ceramics such as higher temperature resistance, hardness, and those of a metal such as the ability to undergo the plastic deformation. Composite material is a material composed of two or more distinct phases, matrix phase and a dispersed phase, and having a bulk property significantly form any of these constituents. Matrix phase. The primary phase having a continuous character is called as matrix. Matrix is usually form a ductile and a less hard phase. It holds the dispersed phase and shares the loads with it. Dispersed phase. The second phase is embedded in the matrix in a discontinuous form. The secondary phase is called as dispersed phase. Dispersed phase is usually stronger than the matrix. Therefore, it is sometimes called as reinforcing force phase. Many of common materials including metal alloys, doped ceramics and polymers are mixed with the additives also have a small amount of dispersed phases in their structures. However, they are not considered as a composite material since their properties are similar to those from their base constituents. Particulate composites are created by adding particle of one material to a matrix. The particles will typically account for less than 15% of the total material volume. The particles are added to improve upon some shortcoming of the matrix material. And the next one is fibrous composites. A fibrous composite is a material in which fiber of one material are embedded within a matrix. The fiber carry most of the stress and the matrix serves to hold the fibers in place and to transmit stress between the fibers. The fibers can be short and randomly oriented or they can be long and continuous. Laminated composites. Laminated composites are created by combining layer of composite material. The layer will typically differ in the orientation of the fibers or they will differ in the material itself. Sandwich materials are common in which lightweight materials such as foam or a honeycomb will be placed in between layers of a strong stiff material. So these are the types of composites and their examples: particulate composite and laminar composite and a fiber reinforced composite. So these are the some of the components that are made with these composites. So next is a metal matrix composite. Is a composite material with at least two constituent parts, one being a metal necessarily, the other material may be a different metal or another material such as ceramic or an organic compound. When at least three materials are present, it is called as hybrid composite. A metal matrix composite is complementary to a cermet or made by dispersing reinforcing materials into a metal matrix. The reinforcement surface can be coated to prevent a chemical reaction with the matrix. Next is a fiber reinforced matrix. Is a high performance fiber composite and achieved and made possible by cross-linking cellulosic fiber molecules with resins in the FRC material matrix through a proprietary molecular reengineering process, yielding a product of exceptional structural properties. Through this feat of molecular reengineering, selected physical and structural properties of wood are successfully cloned and vested in the FRC product, in addition to other critical attributes to yield performance properties superior to contemporary wood. This material, unlike other composites, can be recycled up to 20 times, allowing scrap FRC to be reused again and again. Next is a smart material. Smart material, it is also called as intelligent or responsive materials, or designed material that have one or more property that can be significantly changed in a controlled fashion by external stimuli such as stress, moisture, electric or magnetic field, light, temperature, pH or chemical compounds. Smart materials are the basis of many applications including sensors, actuators or artificial muscles, particularly as a electroactive polymers. There are a number of types of smart materials of which are already common. Some examples are as following. Piezoelectric materials that produce a large voltage when stress is applied, and since this effect also applies in a reverse manner, a voltage across the sample will produce stress within sample. Suitably designed structures are made from these materials can therefore be made bend, expand or contract when an voltage is applied. Piezoelectric materials or produce an electric current. There are several materials that are known from the time that possess piezoelectric properties, including bone, proteins, crystals and ceramics. However, in May 2012, it was announced that University of California, Berkeley lab scientists have found a mechanism of harnessing piezoelectricity from a virus. So this is the first time a biological material has been used to make a piezoelectricity. Shape memory alloys and shape memory polymers are materials in which large deformation can be induced and recovered through temperature changes or stress changes. The shape memory effect results due to respectively martensitic phase change and induced elasticity at a higher temperature. So these are the two different types of shape memory alloys. One way and two-way shape memory. One-way memory effect, which is used in a cold state, and two-way memory effect, which is used at a one is used at a low temperature and the other one is used at a higher temperature. Pseudo elasticity is a common phenomenon called super elasticity, but it is accurately described as a pseudo elasticity. Implies that atomic bond between atoms stretch to extreme length without incurring plastic deformation. Insulators. Insulators are material that exhibit the flow of electrical current, the opposite of conductors, which allow electric particles to flow freely. Insulators are implemented in thermal insulation, similar, but it consists of the flow rather than things. Semiconductors or materials which have conductivity between conductors and non-conductors. Semiconductors can be pure elements such as silicon, germanium, compounds such as gallium arsenide or cadmium selenide. Plastic. So it's a material consisting of a wide range of synthetic or semi-synthetic organic compounds that are malleable and so be molded into solid objects. So they are the advantages are a highly recyclable, high impact resistant, reshaping, and disadvantages are expensive and it can be melted if heated. So thermosetting polymers, it has a more resistant to high temperature, high flexible design and a thick to thin wall capabilities. Disadvantages, it cannot be recycled, and it is more difficult to make the surface finish. So this is about some of the engineering materials that are used.